Dear students, today let us learn Coulomb's law, and after knowing the basic things of electrostatics, we can now next come to Coulomb's law. Now first of all, you must know the law. The Coulomb's law states that the force of attraction or repulsion between 2 point charges is directly proportional to the product of the magnitude of the charges and inversely proportional to the square of the distance between them. Now, this definition or this law you have been learning in school, but let us now explain the law. Now, let us take 2 point charges. Okay, so let us take 2 point charges, say Q1 and Q2. Now, this Q1 and Q2 are separated by distance r. Now obviously, if Q1 and Q2 are both positive, they will experience a force of repulsion. They will both experience a force of repulsion. Now according to Coulomb's law, the force of here repulsion is directly proportional to the product of their charges and inversely proportional to the square of the distance between them. It's also known as inverse square law. So you can write it as F proportional to Q1 Q2 divided by R squared, or you can write it as F equals to some constant K Q1 Q2 divided by R squared. Now in SI unit, this constant K in SI unit, this constant K, you can write it as F equals to 1 by 4 pi epsilon naught Q1 Q2 divided by R squared. Now this constant epsilon naught is known as permittivity of free space. Now this is known as permittivity of free space or constant of vacuum. This epsilon naught in SI unit has a value of 8.85 into 10 to the power of minus 12, and if you want to write the unit, so the epsilon naught goes upwards, it becomes Coulomb square per Newton per meter square. So epsilon naught Coulomb square Newton Coulomb square, okay, and per Newton per meter square. That's the value of epsilon naught. Now, if you want to write the whole value of 1 by 4 pi epsilon naught, it is 1 by 4 pi into 8.85 into 10 to the power of minus 12. Now this value comes out to be approximately 9 into 10 to the power of 9. So that's the value of epsilon naught, and this is the value of 1 by epsilon naught, so it will be Newton meter squared per Coulomb square. That's the value of 1 by 4 pi epsilon naught. So you can write it as value of force F is equal to 9 into 10 to the power of 9 into Q1 Q2 divided by R squared. Now this is the value of force in vacuum. So you can write it as the value of the force in vacuum is 9 into 10 to the power of 9 into Q1 Q2 divided by R squared. Now, if you want to write the expression for Coulomb's law for any other medium, we can write it as, for any other medium, F, say medium, we can write it as F equals to 1 by 4 pi epsilon naught. In place of epsilon naught, we just write epsilon. So 1 by 4 pi epsilon, and then Q1 Q2 divided by R square. Okay, so F vacuum is 1 by 4 pi epsilon naught Q1 Q2 divided by R square in vacuum, and this is for the medium. So we write an expression number 1 and this is expression number 2. Now if you divide one by the other, it becomes like this: F vacuum divided by F medium. The value comes out to be everything cancels. So F vacuum by F medium, it comes out to be epsilon by epsilon naught. Epsilon by epsilon naught. This will give you the value. Now this epsilon by epsilon naught is also known as the relative permittivity. What is this? This is called the relative permittivity. It's called the relative permittivity, or sometimes it is also known as the dielectric constant. So it is denoted by epsilon naught, or sometimes it is also denoted by K, and it's known as the dielectric constant. So from here we can define dielectric constant. So what is dielectric constant? Dielectric constant is the ratio of the force between two charges separated by any distance in vacuum to the force between the same two charges separated by same distance in a medium. So that is the definition of dielectric constant. It is F vacuum by F medium. So one thing more, after learning the definition of dielectric constant, we can now learn what is the unit of charge. So next thing from Coulomb's law that we can do is to find out the unit of charge. Now what we know is F equals to how much? 1 by 4 pi epsilon naught Q1 Q2 divided by R square. Now for vacuum, so for vacuum, this is 1 by 4 pi epsilon naught Q1 Q2 divided by R square, and for any other medium we can write it as 1 by 4 pi epsilon naught into epsilon naught Q1 Q2 divided by R square. Here epsilon naught is the relative permittivity. Now for air vacuum, epsilon naught can be taken to be 1 for air or vacuum. For air or vacuum, we can take epsilon r to be equal to 1. So we can write it as F equals to 1 by 4 pi epsilon naught Q1 Q2 divided by R square. Or you can write it as F equals to 9 into 10 to the power of 9 Q1 Q2 divided by R square. Now to define the unit of charge, what we do is we take, let Q1 be equal to Q2 be equal to Q, say, and then let us take F equals to 9 into 10 to the power of 9 Newton and R equals to 1 meter. So if you place this force as 9 into 10 to the power of 9, R is 1 meter, then what you get is Q square is equal to 1. Or you can write Q equals to plus minus 1. From here we can define charge. So if you want to define charge, you can say that there are from here you can define the Coulomb of 1 Coulomb of charge. So how we define 1 Coulomb of charge is defined as a force of repulsion between two charges. Okay, so two charges here is Q1 and Q2 is equal to Q. So Q square equals to 1 or Q equals to plus minus 1. So here you can say this is 1 coulomb. If you want to say this is 1 coulomb of charge, then the force of repulsion between these two charges must be equal to 9 into 10 to the power of 9, and distance between them will be 1 meter. So if this is the case, then we can define 1 coulomb of charge. So the last definition of 1 coulomb of charge, we can say that 1 coulomb of charge is that charge which experiences a force of repulsion of 9 into 10 to the power of 9 when those charges are placed at a distance of 1 meter from them. That's the unit of charges. So for now, thank you. So we'll continue in the next class.